Hello folks, let's quickly come back to this part 5 video of the exercise 13.1 and these are sensitive things, I have to be really careful, otherwise it will make me do double work. Yeah, thank you. Right, so we are starting with part 5 video and up to the 26th problem, just the opposite of what we did before, right? And again, like before, I have forgotten to write what is it to be. Limit as x tends to 0 f of x. That's what we have to find. Limit as x tends to 0 f of x, like what we did before. We have to find limit as x tends to 0 f of x. Now, again, from left side, right side, we'll see how it is, and then we'll try to decide how the function is. Now, this, if it's at 0, on this side of 0, whereas x is less than 0, at this place, the function is x by minus x, and at this place the function is x by x. So accordingly we should check if the values are going to be the same or not. Left limit right away here. Left limit is limit as x tends to 0 from the negative side f of x, which by formula is going to be x by minus x, and that net effect it's going to come as limit as x tends to 0 minus 1, which is minus 1, and right limit is limit as x tends to 0 plus f of x, that is limit as x tends to 0 x by x. So that's 1. Limit as x tends to 0 1, which is 1. So since left limit is not equal to right limit, so therefore limit as x tends to 0 f of x doesn't exist, does not exist. Right, next one is pretty simple, not so brain hacking, right? Limit as x tends to 5 f of x, modulo of where the function is modulus of x. Right away we can start here. Limit as x tends to 5 f of x is limit as x tends to 5 function is modulus of x minus 5. But look at the domain, or look at the limit. It is x tending to 5, close to 5, means in the vicinity of 5, means it's near 5, right? So 5 is here, we are looking out for nearby values. Now look at the modulus value near 5. Here it will be like 4 point something, and there it will be 5 point something. In any case, modulus of x is going to be x or not, because it's a positive domain, right? So that way it simplifies our work. Limit as x tends to 5, this will be x minus 5, because modulus of x is x in the positive area. So it is x minus 5, which allows you to do the substitution, and that way you get 5 minus 5 equal to 0. Your answer comes up to 0. Right, that's it, right? Now 28th problem, break a function with x defined in different like function defined in different ways at different places in the real number line, and they tell us the limit value is, all this time we have been finding the limit value, but here now they are giving us a limit value and they ask us to find a and b, and these are the kind of problems that's very important from the 12th standard point of view. When we analyze questions on a concept which is maybe father of this limit, something like continuity, a little more mature than limits. There is a concept called continuity. So when we look out for continuity problems, generally there is a trend of asking questions from continuity in the board exam, and generally 9 out of 10 cases we observe that from continuity they ask this A-B kind of questions, where they give you continuity and they will tell you that find A and B. So it's a flavor of that we are going to get in this question, that they have given you the limit, and all this time we were finding the limit. Now they have given you the limit, but they ask you to find an unknown in the function. So you should know this idea, because it's important from the 12th standard point of view. So let's work out. Let's also whether we have understood the function, we should understand. One is here, this is on the left side, and this is on the right side, where x is less than 1, here x is greater than 1, and less than 1 means here the function is defined as a plus bx. At this point the function is defined as 4, and at this point the function is defined as b minus ax. So that's how the functions are going. They ask us to find out the limit as they ask us to find out a and b. So here let's find out the left limit line. Here left limit is limit as x tends to 1 from the left side. So 1 from the left side, by definition it is a plus bx, which means you do substitution a plus b times 1, which is a plus b, and then right limit. Right limit is limit as x tends to 1 plus f of x. That means limit as x tends to 1, but from the other side, b minus ax. So you can do a substitution b minus a, b minus a into 1, but that is a itself. So if you want you can write, but then by this time we have become experts. So b minus a. So that way you've got the left limit and right limit. So like that you can get limit, therefore limit as x tends to 1 f of x. From left side they say is f of 1, which is 4. F of 1 means at 1. At 1 it is 4. So from left side it is a plus b equal to 4, and from right side limit as x tends to 1 plus f of x is 4, which means it is b minus a is 4. So we have a bypass here, right? So we have a plus b equal to 4. We have a plus b equal to 4 and b minus a equal to 4, or minus a plus b equal to 4, right? So solving, that means adding or subtracting. Suppose we are adding, so when we add, a will go b plus b to b equal to 8. B will become 8 by 2, which is 4. Then you can put it in any one of the equations. Since a plus b is 4, so a plus 4 is 4. So a is 4 minus 4, 0. So a is 0, b is 4. That's what they've asked us. What is a and b, right? Very important and very crucial, right? So this is how we are going to work it out. Now, once we are done with that, we are going quickly to the 29th problem. Also very easy because it's a polynomial function. Just check polynomial function. Polynomial functions are always trouble-free functions. They don't demand for much work. Your work is very easy. So let's see. First they have asked us to find out here. First they ask us to find out limit as x tends to a1 times f of x. a1 for the function f of x. So a1, x minus a1, x minus a2, and so on, x minus a. We are substituting a1 minus a1, a1 minus a2, and so on, a1 minus a. But unfortunately this is 0. a1 minus a1 is 0, and 0 into anything is 0. So overall this is going to become 0. And they ask us to find limit as x tends to a f of x. So that way we will have the a substitution. Same thing, limit as x tends to a, function is x minus a1, x minus a2, and so on, x minus an. So when we substitute, it's a minus a1, a minus a2, and so on, a minus an. So what we will do, yeah, that will be our final answer. I hope that is only asked. Limit as x tends to a1. Yeah. What is limit as x tends to a? That's the answer. Quite simple and straightforward. So having done this, so that is going to be our solving of the problem number 29. Now with the remaining problems we can come in the next video. Thank you.